Hey, this is AP Calculus AB 2016, the actual AB test free response questions. We're going to start with number 3, and so here's a printout of the blank sheet for number 3, so you have a graph like this. I've gone ahead and drawn it on my whiteboard, and before we get started, I want to all of these triangles along the way, we're going to eventually have to get the area of those triangles. So let's just go ahead and do that first, and then we'll start answering the questions. Okay, so for this triangle that goes has a base between -4 and -2, we have 1/2 base, so 1/2 times 2 times the height, which is 4. So that's going to be 1/2 times 2 is 1 times 4 is 4. But since it's below the x-axis, we're going to give that a value of -4. This triangle, 1/2 base times height, the base is 4, the height is 4, 1/2 of that is going to be 8. So I'm going to put that 8 just right in the middle there. Same thing for this triangle, 1/2 base times height, the area is 8. For this triangle, 1/2 base times height, the area would be, and it's not the area, but the value under the curve is going to be -8. And then for this last triangle between 10 and 12, 1/2 base times height, -4. So we're going to use those areas to answer part C and part D. Another thing to remember is this is a graph of F, but it's also a graph of G prime, because they tell us that G is equal from 2 to X of f of t dt. So to get g prime, we would plug in the upper limit and multiply by the derivative of that upper limit, which happens to be 1. So that just tells us that g prime of x is equal to f of x. So this is a graph of g prime, and that allows us to answer a lot of questions about g. Okay, the first question is, does g have a relative minimum or a relative maximum, or neither at x equals 10? Justify your answer. Well, you can see that g prime is below the x-axis on both sides of 10. So if we were doing a sine line there and we were looking at 10, we'd have negative, negative, right? So it's neither a max or a min. Okay, and your justification is because g prime of x is less than 0 on both sides of x equals 10. Okay, so it's neither a max or a min. Part B says, does the graph of g have a point of inflection at x equals 4? Justify your answer. Well, here's x equals 4, and you can see the derivative has a positive slope to the left of 4 and a negative slope to the right of 4. So we do have a point of inflection at x equals 4, so yes. And the justification is because the slope of g prime of x changes signs at x equals 4. In fact, to the left of 4, it's concave up because it has a positive slope. And to the right of 4, it's concave down because it has a negative slope. So, although this problem in parts C and D is a little bit of a pain, parts A and B are really easy to get and really easy to get quickly. So you always want to try to nab those easy parts of these free response questions. Okay, so pause if you need to. I'm going to erase and we'll see if we can get part C and D on this little whiteboard. All right, part C. The question says, find the absolute minimum value and the absolute maximum value of G on the interval from -4 to 12 and justify your answers. Let's go ahead and give the justification first, and then we'll do the math. And the math's going to involve all these areas here. Okay, so minimums occur where G prime of X goes from negative to positive. Okay, so we know we've got a minimum. Where does it go from negative to positive? At -2. Okay, now that's not the answer they're looking for. They want the absolute min and max. So I've got to get the y value there. But that's my justification. And maximums occur I guess that's not plural. Sorry about that. Where G prime of X goes from positive to negative. Where does that occur on this graph? Well, it's just one spot at 6, okay, because it doesn't go below the line at 2. All right, so at x equals 6. So we're going to test those 2 points. We might have an absolute min and an absolute max there, but we also have to test our endpoints, -4 and 12. There's 4 points we have to test, and I really don't have room to do it unless I erase this. So pause the video and come back with me in just a second. Okay, so here's where we're going to figure out the absolute max and the absolute min. Let's plot or make a table here. X, G of X. We know we have to test the endpoints, -4 and 12. We know we have a min at -2. We know we have a max at x equals 6. And we also know that the other endpoint is 12. Okay, so first of all, let's see what our y value is, our g of x value is at -4. Okay, so this is how you do it. G of -4. So it's not G prime at -4. We know that. That's -4. We have to get the G of -4. And the way that you get that is you use this relationship, this integral here. Okay, so it's from 2. So we have that, and x is -4. So from 2 to -4 of f of t dt. Now we have to reverse this because we need to get the smaller limit of integration on bottom. Okay, so that's going to be equal to negative -4 to 2 of f of t dt. And this is where we're going to use the areas. So we have a negative, that's the negative there. What's the area under the curve from -4 to -2? Well, that's -4. And then the area from -2 to 2 is +8. So that's negative 4 plus 8 is 4, and then you've got a negative out front, so that's negative 4. So that's our y value, negative 4. Okay, let's look at our next point, negative 2. All right, so g of negative 2 is going to be from 2 to negative 2, right? The value that you're wanting goes right there for x of f of t dt. I've got to reverse those limits of integration, so minus negative 2 to 2. And now it's a matter of the area under the curve. So we've got a negative out front. The area under the curve from negative 2 to 2, well, that's 8, right? But we've got that negative out front, so your value is negative 8. You know how to do it, not too hard. Okay, I'm about to erase all this. We'll get the other two values. Now let's get g of 6. Okay, that's going to be the area under the curve from 2 to 6. Remember, our 6 goes right there. Of f of t dt. This one's not so hard. I don't have to change anything. The area from 2 to 6, right, is 8. All right, that's easy. And then we need to get g of 12. So that's going to be from 2 to 12 of f of t dt. Okay, so from 2 to 6 we have 8. All right, 2 to 6 we have 8. From 6 to 10 we have negative 8. And from 10 to 12 we have negative 4. So that's going to be negative 4. Okay, so hold on just a second. Pause if you need to, and because I need to erase all this. So negative 8 is our absolute minimum. Positive 8 is our absolute maximum. So that answers C, and we did all that work to get there. You know, it takes a lot of time to do that. This is one of those problems where maybe you answer A and B and then you move on and try to come back to it if you can. Okay? So we need to take a look at part D. So it asks us, where is g of x less than 0? Okay, so we see that g of x, we're starting at negative 4 here, negative 4, and then by the time we get to negative 2, we subtract 4 more. So g of negative 2 is going to be negative 4 plus another negative 4, right? You start there, negative 4, and then you have the negative 4, so that's negative 8. All right? G of, you don't get to 0 until you get to g of 2. G of 2 is going to be the negative 4 you start at negative 4, plus another negative 4, which is this, plus 8. That's 0. So you have a g of 2 is equal to 0 right here. So your first interval, so we're still on D over here, is between negative 4 and 2. Okay, g is less than, or it said, or equal to 0, so that's why I've got less than or equal to 0 here. So then we get to positive numbers, g of 6. Let's look at g of 6. Well, it's going to be the 0 that you start at 2 plus another 8. And then how about g of 10? Well, g of 10 is going to be Okay, at 6 you're 8, but then you subtract 8 between 6 and 10, so minus 8, so 0. So we're back to 0 right here. And then it goes negative after that. So your second interval is between 10 and 12. Okay, so you just kind of have to follow the areas. And if you haven't worked a lot of those, it's kind of slow going. So again, this is one you need to know how to do it. Could be an answer on a multiple choice that you could get pretty quick, but on a free response like this, definitely worth knowing how to do. But I'm not sure that you would have the time really to get it. Okay, let's move on to number 4. Okay, number 4 says we have dy dx is equal to y squared over x minus 1. And they've given us a slope field that we've got to draw. Okay, so the points we have to draw are here, 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 and 3 at 2. So at okay, so I'll draw those slopes in. So we've got 6 points we got to figure out. So let's just do them a point at a time. We'll make a little table. So our first point is at 0, 0. And to get the slope, we just plug the numbers in. That's dy dx. You know, if they had given us y, we would have had to take the derivative and then plugged it into that. But they gave us the derivative, so that's cool. So 0 over 0 minus 1 is 0. So let's go through all the points. There's another one at 0, 1, 0, 2, and then we've got 2, 0, 2, 1, and 2, 2. All right, let's plug all those in. If you plug 0, 1 in, you'll get negative 1, negative 4, 0, 1, and 4. And we've got to draw those slopes. Well, a slope of 0 is pretty easy. Doink, like that. And then a slope of negative 1, so that's kind of a 45-degree negative angle, something like that. And then a negative 4, super duper steep, right? Negative. And then the other 3 at 2, 0, we've got 0, positive 1, and then positive 4. You don't have to be perfect, but you know, do your best to differentiate between positive 1 and positive 4, negative 1 and negative 4, and they'll probably be good with that. Okay, let's see. So that's part A, and I'm telling you right now, you can get that one. You can get some points on that one. Let's see if I can fit part B here. So it says, let y equals f of x be the particular solution to the differential equation with the initial condition f of 2 equals 3. Write an equation for the line tangent to the graph at x equals 2. Okay, so our point that we're worried about is 2, 3. So the slope at 2, 3, we're going to use dy dx formula, so it's going to be 3 squared over 2 minus 1. So that's 9 over 1, which is 9. So our tangent line equation is going to be y minus y1, so y minus 3 is equal to 9 times x minus 2, right? I would leave it like that. You don't have to solve for y. You know, make them worry about that. And then to get your estimate of 2.1, you're just going to plug 2.1 in for x there. So that's y minus 3 is equal to 9 times 2.1 minus 2. So y is equal to 3. plus 0.9, right? And so that's 3.9. Okay, so this part A and part B, you have got to get this. I mean, this is one you can get fast. You've done this a lot in your homework problems this year. You're just all over this like stink on a monkey's butt. Okay, so let's do part C, which is also not too bad. All right, part C is, they give one like this every year. You've got to separate the variables. You need to show every step, and it's usually worth something like 5 points. Okay, so a pretty big deal. So it says find the particular solution at the point 2, 3. Okay, we got to separate our variables here. So I'm going to cross multiply. So we'd have x minus 1 times dy is equal to y squared times dx. And then I'm going to pull that y squared over here, dy over y squared, and bring the x minus 1 underneath over here. So our variables are separated. We've got to integrate. Okay, that's the same as y to the minus 2 dy. And integrating that's going to be the natural log of the absolute value of x minus 1 plus c. Okay, so integrating this, it's going to be y to the minus 1, but I need a minus out front. So that's going to be minus 1 over y is equal to the natural log of the absolute value of x minus 1 plus c. Let's plug our numbers in to get c. So I'd have minus 1/3 is equal to the natural log of 2 minus 1 is 1 plus c. We know that natural log of 1 is 0. So negative 1/3 is equal to c. Boom, we're almost home. So let's plug that in there. I've got negative 1 over y is equal to the natural log of the absolute value of x minus 1 minus 1/3. Now we need to just solve for y. Let's multiply both sides by y and divide both sides by that. So you'd have y is equal to negative 1 over the natural log of the absolute value of x minus 1 minus 1/3. So I would leave it like that. You know, you could multiply the top and bottom by 3 over 3 to get rid of that fraction. I probably wouldn't worry about doing all that. If it were multiple choice, then you might have to do that to match the answer. But on free response, I would make them tell you that's wrong. And they don't have any ground to stand on, in my opinion. So number 4, whereas number 3, the last two were pretty hard. Number 4, you could ace that entire problem. Okay, so that does it for this video. Actual 2016 free response question number 3 and number 4.